The electrophoresis is a technique commonly used for separating charged molecules as DNA, RNA, and proteins. Some applications are verified amplifications by PCR, check quality and quantity of genomic DNA after extraction, protein analysis, and identification of bacteria isolated from clinical samples. Some aspects to be considered is the preparation of the agarose gel, which goes from 1 to 2% depends on the size of the molecule. The preparation of the electrophoresis buffer, which is going to be helpful for the migration of the molecules. The preparation of the loading buffer for increasing the density of the sample and avoid the floating. The selection of the marker, if it's for DNA or RNA. Putting the gel in the tank for the electrophoresis according to the electrode's orientation. Turning on the electrical current during a specific time for migration, avoiding high voltage because degradation. And using a fluorescent dye for visualizing our sample in the UV transilluminator. The pulse field gel electrophoresis is a method applied in separating large segments of DNA using an alternating and cross field that periodically change direction. This method is useful for epidemiological studies and gene mapping.
As a result of the electrophoresis, two images were obtained. Image A represents the gel with 0.8% agarose and image B with 1.16% agarose. Both gels were prepared with TBE buffer and run at 110 volts for 1 hour. The gel wells were loaded with 3 microliters of loading buffer and with various samples to compare their migration pattern. The first 3 samples are markers. Sample 1 are 7 microliters of fast DNA leader. Sample 2 are 3 microliters of too long leader, and sample 3 are 3 microliters of marker of 100 base pairs. Sample 4 are 6 microliters of genomic DNA from Escherichia coli. Sample 5 are 6 microliters of opossum RNA. Sample 6 are 5 microliters of plasmid. And sample 7 is 1 microliter of ribosomal 16S PCR, product of 450 base pairs. In samples 4, 5, and 6, the presence of the proteins in the wells is observed. These remain in the well since they are very heavy and cannot run under these conditions. In the upper part of both samples, number 4, DNA can be distinguished, while in the lower part, RNA contamination is observed. This happens because the folded structure of DNA prevents it from running the same distance from RNA. In sample 5 of gel A, 3 bands representing different forms of RNA are observed. In contrast, in sample 5 of gel B, runoff of the band is observed, which means degradation of nucleic acid. Finally, bands 2 and 3 of both gels are distorted, probably due to an excess of sample.
Electrophoresis is a technique used to separate DNA fragments according to their size. The DNA samples are loaded into wells on one end of the gel, and an electric current is applied to drag them through it. The fragments are negatively charged, so they move towards the positive electrode. Since all DNA fragments have the same amount of charge per mass, small fragments travel through the gel faster than the large ones. When the gel is stained with a pigment that burns to the DNA, it can be observed as bands. Electrophoresis can be performed on agarose or polyacrylamide acids. Both have different characteristics in terms of their properties and mode of preparation, so they are used according to the objective. Agarose gel electrophoresis is the standard method for separating and purifying DNA fragments when high resolving power is not required. However, the size range that can be applied much higher in an agarose gel depending on the concentration of the same. The lower the concentration of agarose, the larger the size of the molecules that can be separated. In the extraction and purification of DNA, successful results were obtained since in electrophoresis the bands could be distinguished even though with contaminating proteins the measure could be clearly seen. For RNA, the two bands that should be separate are observed but seem a little more clear and round. The sample is degraded.
Some of the components used in electrophoresis techniques of DNA are toxic, and special precautions must be taken in their handling. DNA electrophoresis techniques are now basic and irreplaceable for at work in molecular biology with nucleic acids, so they will continue to be used for a long time. The continuous development of molecular biology techniques suggests that new applications in the different yields nucleic acid DNA electrophoresis techniques, especially electrophoresis, agarose, is a basic and essential technique in any laboratory that uses molecular techniques with DNA, even at the most basic level. At the time to set a molecular biology laboratory, the first thing to consider is the actioning of the necessary equipment for the realization of electrophoresis in agarose cells. It's essential an electrophoresis chamber with your accessories and a power supply, as well as a transilluminator and a photo documentation system. The cost of this equipment are affordable and they do not require large investment.